Hello everyone, myself Purushotham, working as Assistant Professor in Department of Computer Science and Engineering, MLR IT. In this session, I am going to explain about the multi-threading concept. Okay, so this is the overview of this session. So in this session, I am going to talk about what is a multitasking and the types of the multitasking and the differences between the multi-threading and the multi-processing I am going to explain now. Okay, so let's get started today's session. So first of all, coming to what is a multitasking. So the definition of the multitasking: executing multiple tasks at a time is called multitasking. It's very simple definition. Executing the multiple tasks at a time means simultaneously if you are performing what the more than two tasks, so it is what the multitasking. So or another definition, ability to execute more than one task at the same time is known as a multitasking. Okay, so this is one more definition: ability to execute more than one task, or if you are performing the multiple tasks simultaneously, it is a multitasking. So suppose if you take an example, so here you can see the picture, the person is doing what the multitasking here. Okay, so if you observe this picture, the person is eating, at the same time he is doing some work. Okay, so eating is one task. Eating is one task and doing work is another task. Okay, so now two tasks he is performing. Now his mind will be, means his mind switch between this eating and his work. Okay, so this is what the multitasking. Now this multitasking can be divided into two types. One is a process based multitasking and second one is a thread based multitasking. Okay, so these multitasking we can divide in two ways, like process based multitasking. So based on the process we can divide what the multitasking, and based on the thread also we can divide this multitasking. Okay, now so before discussing what process based multitasking and thread based multitasking, first let us discuss what exactly a process and what exactly a thread. Okay, so now we will see what is a process and what is a thread. Okay, so the process. So what is a process? In operating terminologies, in operating system terminology, a process is a program. A process is a program that is currently in running. Okay, so in your operating system you may have the different kinds of applications are there. In the different kinds of applications, like suppose if you take an example, the Chrome is one application or one program. If the program is open, or if program is what in running mode, okay, so that state is nothing but it is a process. Simple. So one more definition: a process is basically program under execution. The programming currently running or program under execution are same. Okay, so a process is basically a program under execution. Okay, so this is a one more definition. And one more definition: a process is basically a program in active or running mode. Okay, means simple, nothing is there. So suppose if you take an example, so I have a Chrome application. Now the Chrome application, now it is not open, means now the Chrome is in idle state. If I open this Chrome, now the Chrome is open, means the Chrome now it is in running mode. Now the Chrome state is changed to program to process. Simple. Okay. Now if you want to check, you can open what the process table, like if you open the taskbar, you can see the process table. This is the process table, you can see. So here you can see the apps. Now the Chrome is open. Now you can see, now whatever you are seeing in the background, that is the Chrome is open. Now the Chrome state you can see under process state. Okay, now I want to close this Chrome. Now you can see I will end this task. Now you can see there is no process related to what to Chrome. Okay, now again if I open the Chrome, now the still Chrome mode is a program mode. Now if you open this Chrome, now again you can check. Yeah, now you can see here, now program is open, means the Chrome is open. Now again the Chrome mode is what the process mode. Simple. So what is the definition of the process means? Simple, the program that is currently in running or the program under execution or the program is in active state or running mode is nothing but the process. Now, what is a thread? A thread is a flow of execution in a program or process. A thread is a part of the program, or a thread is a tiny program running continuously. It is also called sometimes lightweight process. Means simple. Process means it is entire program. Thread means it's a part of the program. So suppose take an example. I have a program. Now this program is having what, some 100 lines of code. Assume. So here this program is having 100 lines of code, LOC. Now assume the first 25 lines is individual independent part. So we can treat it as a what, thread 1. And next independent lines of code. So let's take an example, next 50 lines. So treat it as what, thread number 2. And next thread, next 50 lines of code, what, now thread 3. Next last 100 lines, I will treat it as what, thread number 4. Now I have what, multiple threads here. Now if you observe, thread is a part of the program. Now you can see this entire thing is a program. Entire thing is a program. Now threads are the part of the program. Okay, it's not entire program, just it's a part of the program, just some portion of the program. So every program may have what, multiple threads. Okay, so at least one thread, or every program may contains what, at least one thread or multiple threads. So simple, a thread is a flow of execution in a program, independent part of the program, or it is just a part of the program, or the program, it is a tiny program running continuously. So these are the different definitions of what, thread. Now, so coming to what, the process and a thread. Just now I explained. Now if you observe the internal process, as I mentioned, if the program is an idle state, like suppose if you take an example, Chrome. Now if you are not open the Chrome, now the Chrome is saved in your hard disk, HDD. Now the mode of the Chrome is a program only. Okay, now every program, as we know that every program is having some instruction. Okay, so let's take an example. So this Chrome is having n instructions. Now, so whenever your Chrome is open, means whenever your Chrome is open means whenever you are instantiated. Whenever you are open means now the Chrome mode will be changed to what, earlier in idle state it is a program mode. In idle state it is a program mode, and whenever you are initiated, so means whenever you open the Chrome, that program will be converted to what, the process. Means whenever it is idle, it will store in the hard disk only. So whenever you are opening any application, that will be loading to what, the main memory, physical memory, that is what, RAM. Now if the program is loading into the RAM, the state of the program is technically will call it as a process. So program only, but the program, if it is there in the hard disk, we can call it as an application. The program, if it is there in the hard disk, we can call it as a what, application. But if the program, if it is initiated, means if it is opened, so automatically it will load into what, main memory, and in main memory the state of the program, technically we will call it as a process. Okay. Now every RAM may have what, the multiple process. So let's take an example. Here I have what, 3 processes, process 1, process 2 and process M. Now so every process have what, threads. Okay. So as we know that a thread is a part of the program or the part of the process. So let's take an example. Here I have what, the multiple threads. So these are the multiple threads. Now these threads having what, the priorities, high priority, low priority and medium priority. So here which thread has to be executed on the CPU. So this is the CPU. Now here we have what, the different kinds of threads. Now these threads we need to run on the CPU. Now how these threads will be executed on the CPU means, who will decide means, the thread scheduler will be decide. Thread scheduler, how it will decide means, the based on the operating system algorithms, like thread scheduling algorithms, first come first serve, like shortest job first, round robin, okay, the priority. So depends on the what operating system algorithm, thread scheduling algorithm. So the particular thread will be pick. Okay, so suppose assume the thread 1 got a chance to execute. Now the thread scheduler will be picked from the what the thread pool, and that thread will be run on the CPU. Okay, so this is the execution order of what a program. Okay, so now we'll discuss. So now we know what the process, and now we know a thread. Now we'll see the definition of what process based multitasking. Okay, so a process based multitasking, it is very simple. In process based multitasking, the 2 or more processes or programs are run concurrently. Okay, now if the 2 or more processes run parallelly, so then it is called what the process based multitasking. In process based multitasking, the program is the main. Okay, so based on the program only we are defining this a process based multitasking. So the program is the smallest and fundamental unit. Now, so suppose if you take an example, in real time example. So here you can see we can listen music and browse internet at the same time. So you can listen music and you can browse the internet. Means here to listen the music we may use any media player application. So media player application, and to browse the internet you may use any browser. Means here the CPU will be switched between what media player application and the browser. Now it is one process and it is another process. The CPU will be switched between these 2 processes. Okay, so this is a process based multitasking. Thread based multitasking, it is also similar to what the process based multitasking, but here we will use only thread, that's it, nothing is there. So in thread based multitasking, the 2 or more threads can be run concurrently within the same program, So in thread based multitasking, now thread is a smallest unit, just like in previous the process based multitasking, the program is the smallest unit, and in thread based multitasking, so based on the thread we are defining this multitasking now. So thread is what the basic unit or smallest unit. If you take an example, so while you are typing, the multiple threads are to display your document asynchronously and check the spelling grammar of your document. Okay, so suppose if you take an example, like I have a Word document or any document. So assume if you are writing something, so suppose let us take an example, I am typing something hello, means one thread will be what it displays the text, and one more thread will be executed in the background. So that will be what check the spelling and grammar. Okay, now here within the same program, thread 1 is executing to display the text, and one more thread is executing within the same program, and it is responsible for what the check the spelling and grammar. Okay, so multiple threads are executing within the same program. Okay, or else if you take one more example, like suppose you are browsing internet, to browse internet, assume you are using what the Chrome, and while browsing internet you can download any file, you can download any file. Means for downloading one thread is responsible, and to browse the internet one more thread is responsible. Now you can see guys, here the downloading and the browsing internet can perform within the same program, means that is a Chrome application. Okay, and if you want to download one more file, so again one more thread is responsible. Likewise you can download any number of files. For every download a separate new thread will be created within the same program. Okay, now the CPU will be switched between these multiple threads in your program, in your same program. So this is one of the example. So coming to the differences between the multi-threading and multi-processing. Now we know what multi-threading and we know what multi-processing. Okay, now let's see what is the difference between multi-threading and multi-processing. Now as we know that in multi-threading the fundamental unit is what a thread. Why? Means based on the thread only we are defining a multi-threading. Okay, so in multi-processing the process or program is a fundamental unit. Why? Means based on the process or program only we are defining what the multi-processing. So next difference, so the definition of the multi-threading and definition of the multiprocessing. As we know that, so executing the multiple threads simultaneously within the same program is multi-threading, and executing the multiple processes or programs what on CPU simultaneously, it is nothing but what the multiprocessing. Okay, so this is a definition part. Next, in multi-threading, the CPU will be switched between the threads. So here a CPU will be switched between what the threads. So let's take an example. I have what the 4 threads. Now in my program, assume I have 4 threads. Now 4 threads will be execute simultaneously. Now the CPU will be switched between these 4 threads. Now in multiprocessing, the CPU switches between the processes. So assume I have the 2 processes or 2 programs in active mode. Okay, so let's take an example. The process 1 is a media player application and process 2 is a Chrome application. Now simultaneously these 2 programs are running. Now the CPU is a switch between these 2 processes. Just for your understanding, I am taking only 2 processors here. You can take what? Any number of processes. So if you observe the fourth difference, cost effective, because the CPU can be shared among the multiple threads at a time. Okay, so these 4 threads are the part of the same program. Okay, it will share address of the same program and it will share the what memory of the same program. Okay, so it is a cost effective. We require what the less CPUs. But to improve the computing power in multiprocessing, we need to add what the multiple CPUs. Why means if you increase what multiple processes, if you increase the process count, okay. So to improve the computation power, we require what the multiple processes. Okay. So if you want to add the multiple processes and it leads what the expensive. So it is what the expensive. Multi-threading is a high efficient and multiprocessing is the less efficient. Okay. So how? I will explain next slide. And using multi-threading, we can develop what efficient applications, like you can develop the gaming application, you can develop what computer graphics related application, or you can develop any other efficient applications. And using multiprocessing, you can develop what OS related programs, operating system related programs we can develop. Okay, so these are the differences between the multi-threading and multiprocessing. Now, so why we need to study the multi-threading? Why we need to study the multi-threading means to improve the application performance, to improve what the performance of your application, to improve the response time of your application, we need to study what the multi-threading. Okay, so why means we will see now. So suppose assume I have a program without multi-threading, what will happen now? You can see. So assume here I have what 100 lines of program. So let's take an example. My program is having what 100 lines. Now, so let's take an example. Here I have what 100 lines. So to execute this program without multi-threading, it may take what 100 milliseconds, assume. So for every instruction it takes what 1 millisecond. So to execute this entire program, it may take what 100 milliseconds. Now the same program, if I apply the multi-threading, now what will happen means, you can observe here. So you can see the first 25 lines, assume it is a thread 1, and next to 25 lines, so assume it is a thread 2, next to 25 lines, assume it is a thread 3, and the next 25 lines, assume it is a thread 4. Now assume in my program I have what the 4 threads. Okay, now CPU will be switched between these 4 threads, so T1, T2, T3 and T4. Now to execute the T1, so the T1 takes what 25 milliseconds. To execute the T2, the T2 also takes a 25 milliseconds, T3 also 25 milliseconds, and the T4 also it takes what the 25 milliseconds. Now if you observe, these 4 threads will be executed parallelly, these 4 threads will be executed concurrently, means simultaneously these 4 threads will be executed. Now what will happen if the context is switching, if you ignore that context switching time, if you ignore, so this entire program will be executed approximately 25 milliseconds only. If you are not using what the multi-threading, it may take what 100 milliseconds, but the time is reduced to what, the 25 milliseconds. Means if you are applying the multi-threading to your application, you can improve what, application response time, and you can improve what, application performance. Okay. So the main objective of using the multi-threading is to improve application response time, to improve what, to improve the performance of your application. Okay. So that is the main intention of using multi-threading. So coming to the summary of this session, in this session I have explained the multi-threading definition and the categorization of the multitasking. Next, the definition of a thread and process I explained, and the differences between the multi-threading and multi-processing I explained. Okay. So that's about this session. Thank you.